This is our first lesson for AP Stats, Chapter 1, Lessons 1 and 2. So please download the outline and the vocabulary that are in the Schoology folder, and also use your book. The summaries, especially at the end of Chapter 1, Lesson 1 and Lesson 2, will be extremely important, and there's a little intro you should check out too. So pause the video and grab those now, and download the outline and the vocab from Schoology. So we're looking at data, and this is real basic. We start with chapter 1. So individuals, objects described by a set of data. Variables are characteristics that may vary. So individuals may be variables may be age, gender, favorite type of music. Categorical variables describe categories, not numbers, while quantitative variables are quantities or numbers. So keep in mind as we go what the different types of variables, data, and distributions we can use to learn more about something are, what's involved with each of these, and how you might be able to use these strategies when putting together work for your project. So a distribution of a variable tells us what values it takes and how often it takes. You might just call it a graph. We can take many different forms. We're going to be using the word distribution throughout the year, so it tells us about the values that a variable takes and how often or how much frequency it takes them with. So that's what we're talking about with the distribution. We want to be able to make inferences. That means figure things out, draw conclusions. We'll talk about how a simple random sample from the population and a random assignment when we're dealing with an experiment will help us out. A simple random sample will help us get a good sample that should be representative of the population we took it from if it's truly random, and random assignment will let us know cause and effect if whatever we're experimenting with, whatever our treatment is working. So here's some ways we can display it. Dot plots, little dots telling us how often a value is taken. Stem plots, which are the numbers with the larger values as branches, and then or stems, and then the leaves are the individual values in the ones column or the tenths column depending on the data. Box plots will really show us how spread out our data is, where it's centered. They break it up into quartiles and use the median to show us where the data is and if they're skewed, meaning if there's more data on one side than another. We'll keep talking about those. Bar graphs you should be familiar with. A bar representing each category. That can be alright for categorical variables. We're not going to use a lot of bar graphs because they generally don't give you as much information. And pie graphs, a circle representing data, we also don't use those as much. A histogram is what we'll use instead of a bar graph. It's basically like a dot plot but with bars instead of dots. So a bar graph's usually better than a pie chart. They make it easier to compare data with bars next to each other. So we'll use a bar graph over a pie chart for categorical data. Pie charts really aren't used that much. We're not going to be doing a whole lot with them. We'll just have a little bit that it should represent one whole. Here's an example of a bar graph. And you can see there that we have, this is talking about the recession and Obama coming back and how the stimulus program here and job growth. So Obama takes over in the blue, and then job growth goes from negative back up to positive, and this lets us really compare the data and see how it went from Bush's recession into Obama's stimulus and then the job growth. Here's another type of infographic which we'll be using throughout the year, which shows you about honeybees and their extinction rate, and some cool information using a variety of graphs together. So in the end, a variety of ways of displaying the data tends to be the most effective way to do so. You can see this uses a pie chart of sorts, which is a little different, bar graphs, and then other density curves to show about honeybees and their extinction, which is a major issue right now. Pictographs tend to be horrible ways to represent your data, as the total area of the picture doesn't really, this makes this look like it's a huge. DirecTV is the favorite. When you compare these two, 81's much bigger than 56, but this difference between the two seems small, making this difference of 14 seem huge when it's actually a smaller difference than between these two. So pictographs, our eyes look at it, but they're not really providing us with an accurate picture of the data. So we'll stay away from those. Two-way tables, this is really important. It'll be part of your project, and it's a big part of looking at data. Two-way tables are called two-way tables because they have two variables involved. Here we have data on preferred superpowers, and you have the superpower choice and then gender. So our variables are gender and superpower. Now, a conditional distribution would mean for one value of a variable, what are the values of the second variable? So for females, what do they prefer? So these values in here are all conditional distributions. If given your male, what do you prefer for superpower? These are conditional distributions. A marginal distribution can be calculated with these total columns. So a marginal distribution is what percent of all prefer invisibility. So it only takes into account one variable. So marginal distribution only accounts for one variable. Conditional distribution gives you values of the second variable given a value of the first. So given that you're female, what are the superpower preferences? Or we could do it the other way. Given that you prefer invisibility, what percent are female, what percent are male? So again, marginal, look to the total column because it tells you about values of one variable. Conditional distributions are inside here because for one value of a variable, what are the values of the second variable? So for gender, what are the values? Given that the gender is female, what are the choices of superpower? This we'll use a lot. So conditional distributions inside, marginal on the outside. To consider how to use data, think about what the explanatory variable is, meaning what's the cause, and the response variable or the effect. And that can help us to decide which conditional distribution is best to use. So that can help us decide which way to use these distributions to find answers. Throughout the year, we'll be doing multi-step problems, and they'll all involve stating the problem, planning on how you'll do it, and checking conditions, doing the problem, and then concluding by explaining your answer. Finally, we say there's an association between two variables if specific values of one variable tend to occur with specific values of a second variable. So that means if we think that there's some causation, if we think one change in one thing is causing change in another, then that's an association, meaning there's a cause and effect. Jump into lesson 2, let's look at some ways of displaying data. A stem plot has values as stems and then individual values as the leaves. So this stem plot means that 23 is in our data set, 26, 20, and 22. Now up here, this is out of order. To correctly write this, we have to put it in order. So it would be like, this means that our tens digit is 2 and the ones digit 0. That means we have 20, 22, 23, 26, and then down here 32, 33, 35, 36. So we can see we have more values close to 20 than we do up here by 70, just one, 73. So it tells you that our distribution here is skewed right slightly, meaning we have a couple values very high, pulling our mean up. So this is a stem plot. This is a box plot. A box plot shows us our minimum, the smallest value, here at the left, and the maximum at the right. This line represents the first quartile, meaning a quarter of our data is located in here. This, in the middle of our box plot, represents our median, meaning the halfway point of our data. If we had 15 pieces of data, this would be the 8th piece of data. Our third quartile is here, meaning a quarter of our data lies here, and 3/4 of it lies here. So it's a good way to see how your data is spread out. If we had outliers, meaning values that fall far enough away from the rest of the data, then they'd be marked with an asterisk or an X on the left and on the right. You can also use a vertical representation for your box plot. So this shows you the whisker for the minimum, the 25th percentile, meaning a quarter of your data is here, our median, our third quartile, meaning 75% of the data falls below that, and a quarter falls above, and then the maximum. This is an outlier. Here they mark it with a square. We're going to be using an X or an asterisk. So dot plots, stem plots, histograms, box plots are all good ways to represent our data. I'd like you to focus on 4 aspects of a distribution that we use to learn about our distribution, which is SOCs: shape, outlier, center, and spread. So here's a histogram example. First, let's take a look at what a histogram is. It's like a bar graph, except for it's a quantitative variable, so dealing with numbers. And they're next to each other. There's no gaps in between. We use shape, center, spread, and outliers to describe it. Shape would be like if we drew a smooth curve above the whole thing. We can say this is not quite bell shaped, but it's somewhat symmetric, meaning if we put a line right here, almost mirrored. We also have our maximum here between 75 and 80. Our center is somewhere around here. I'd say a little bit above 75 since more of our data is located here. Spread tells us the minimum and the maximum. So 90 minus 60, our range here is 30. Tells us how spread out the data is. Outliers would tell us if something's far away from the other data. We'll talk about calculating that in class. So this has to do with your free response question. Shape, center, spread, and outliers. We look for any peaks. That's our mode, meaning the values that occur most often. If it's skewed right, that means looks like if we drew a curve above it, if the tail would be to the right of the distribution. Skewed right means it's pulling the mean to the right or making it bigger than it should be, making it bigger than the data represents. So then if it's skewed right, the mean would be bigger than the median. Skewed left means the tail is to the left of the distribution, meaning you have some values far to the left, far smaller. Our center, we use the median if there's any skew. If it's symmetric, meaning looking like a bell, or could be a bell, could be another symmetric distribution, we can use mean. Otherwise, median is going to give us the best idea. Spread, how much variability, the maximum and the minimum. And the range is the maximum minus the minimum. Outliers would fall outside the overall pattern of the graph as being much smaller and much larger. We'll talk about that more in class, how to calculate it. For now, just know an outlier is far smaller or far greater than the rest of the data. So again, symmetric data is great. When we get sampling distributions, we'll tend to get more symmetric data, but we rarely see perfectly symmetric graphs in reality. Biological data, sometimes tool measurements can give it to us. So we'll say approximately symmetric if it's not perfect. If there's skewed right, remember values, you have some values that are much bigger than the rest of the data that are pulling the mean up. If it's skewed left, some values are much smaller than the data pulling the mean down. Here you have approximately symmetric with a nice line of symmetry through there. This one's very close to symmetric. Skewed right, this is what I was talking about. These values are pulling the mean up. So our mean here would be bigger than our median because of these values pulling it up, whereas most of our values are down here. Skewed left, we have some values down here much smaller than the rest, meaning our mean would be smaller than our median because of these values. Unimodal would be a single peak, bimodal 2, multimodal is 3 or more. Okay, here's your multiple choice question. I want you to describe the distribution there. Is it skewed right, skewed left? Is it approximately symmetric? Where is the peak? Does it appear to be unimodal, bimodal? And what's the range? And it's got no clear outliers, so you're given that. So remember, we want to describe shape, outlier, center, spread, socks. A zoomed in version of it in case it was difficult to see the other version. So you're going to enter your multiple choice answer on the multiple choice answer sheet below, and then you're going to answer your free response question about the 4 aspects of a distribution we look at to describe it. So be sure to read the summaries for lesson 1 and lesson 2 in your book, and look at the vocabularies and outlines online, and use that to answer these questions, and think about how you can apply this to a project which you're going to be deciding on soon. This video is a little longer than they'll usually be because it's an intro and we're covering 2 lessons. Keep in mind how we can use all of this in order to pursue your project, and keep in mind what a distribution it is. That it's what values a variable takes and how often.